In this video, we're going to prove the product rule for sequences. If you have two sequences, A n and B sub n, and they're made up of real numbers, and A and B are also real numbers, with the limit of A sub n being A, and the limit as n goes to infinity of Bn equals B, then the limit as n goes to infinity of A sub n times B sub n is just A times B. And we're going to prove this. We're going to use the definition of what's in the blue. The limit as n goes to infinity of A sub n equals A. That's the same statement as given any epsilon greater than 0, there exists an n sub 1, which lies in the natural numbers, such that whenever little n is bigger than n1, we have that A sub n and A is small. The absolute value is less than epsilon. We're going to do the same thing for the other limit. The limit as n goes to infinity of B sub n, that equals B. That's the same statement as given any epsilon greater than 0. It does exist in n2, which lives in the natural numbers, such that whenever little n is bigger than n sub 2, we have that the absolute value of the difference between Bn and B is quite small. It's less than the given epsilon. Okay, this, of course, is the second definition. Now, what we're going to do is we are going to choose n to equal the maximum, the larger of n1 and n2. Suppose for a moment n1 is bigger. Well, whenever n is bigger than n2, we have this is true. Well, actually, if we pick a larger one, like n sub 1, then this statement will still be true. Because any number bigger than n sub 2, this works for. So if n1 is even larger, then it's going to work there too. So choosing n to be the larger of the two doesn't mean anything. So what do we have now? So we have that given any epsilon greater than 0, there exists an n, which is in the natural numbers, because n1 and n2 are in the natural numbers, and n is just equal to one of those two, such that whenever n is bigger than n, we have the following. We have that A sub n minus A is less than epsilon, and B sub n minus B is less than epsilon whenever n is bigger than n, capital N. Now, we want to show that A n B n minus AB is also less than epsilon. n is, if little n is bigger than big N. So what we're going to do is we're going to try to build that up. We have a and b n. I'd really like to have a n minus a. Now, if I put a b sub n next to the capital A, when I factor out the b sub n, I'll have a sub n minus big A, which is great. But I just can't take away a sub bn, so I better add it back. So this is just 0. Let's not forget to take away the ab. This is equal to a sub n. Well, let me just say b first. B sub n. I factor out the b sub n. B sub n times a sub n minus a. That's this part right here. And now I'm going to add on that part. But on that part, I can factor out an a. And I have bn minus b. Looking promising. Now, I'm going to write this just a little bit smaller. The absolute value of bn times an minus a plus a times the absolute value, a times bn minus b. Now, when you have the absolute value of the sum, this is less than or equal to the sum of the absolute values. The sum of the first factor plus the sum of the second factor. Now, in each of these absolute values, we have a product. The absolute value of this times that. The absolute value of this times that. But that's equal to the absolute value of the first factor times the absolute value of the second factor, plus, same game, absolute value of A times the absolute value of bn minus b. But this is less than bn times epsilon, because a sub n, okay, so let me just say this, for n greater than n. Anything below this line is for n bigger than n. Now, this is less than the absolute value of bn times epsilon, because that's less than epsilon, plus the absolute value of a times epsilon, because that's less than epsilon. Now, factoring out the epsilon, we get the absolute value of bn plus the absolute value of a. But what is the absolute value of bn? Can we bound it? The absolute value, a is just some real number. The absolute value of a, we know, it's 17. It's whatever a is. So we need to find a bound for b sub n. So let's do some side work. We know that b sub n minus b, an absolute value, is less than epsilon. That means that it's between b sub n minus b is between plus or minus epsilon. Adding b to both sides, adding b to both sides, so let me not have b. We have this as less than b plus epsilon. So we know that b sub n is less than the absolute value of b plus the absolute value of epsilon. But epsilon is always positive. Epsilon is given to be positive. So b sub n is less than that. So to save space, I'm going to write to the right. Okay. So let's see. So this here is less than epsilon times the absolute value of bn is less than that plus the absolute value of a. Now everything would be fine if we didn't have epsilon in here. So what we're going to do is we're going to choose epsilon to be less than 1. Okay, so then this here will be less than epsilon times the absolute value of b plus 1. I replaced epsilon with something bigger. 1 is bigger than epsilon plus the absolute value of a. Now, let us look at what we have. We have that this, whenever n is bigger than n, is less than this. So I'm going to write this down here. So, for n bigger than n, we have the absolute value of an times b sub n minus ab is less than epsilon times, I just changed the order. Okay, so now we will choose epsilon prime to be epsilon over, oh actually, we'll choose epsilon to be epsilon prime over that. Okay, so then we have, for n bigger than n, we have that. I'm just going to recopy this with one exception. Instead of epsilon, I am going to put that. We have that a sub n minus b sub n, a n b n minus a b, a n b n minus a b. We have that this is less than, well, we know it's less than this, but I just write down the new epsilon. If it is true for any epsilon, at least 1 times this, a plus b plus 1. So that equals epsilon prime. That is, because this cancels out. I showed that if n is large enough, that this is less than some epsilon. But that implies the limit as n goes to infinity of a sub n, b sub n equals ab. And the proof is now done. It's complete. If you have any comments about this video, please leave it. Tell me how much you liked it. Tell me how much you didn't like it. Tell me there was a mistake somewhere. Leave some kind of feedback. Let me know what you think of these videos. If there a proof that you would like me to post a video for, let me know. Most of all, watch and learn.